records or something like that. And then we want to be able to show these guys in a list. Is that the direction we're going? Or the direction that makes sense to go? All right. So let's look at this again. I think Sarah's example from last class threw me off here when I opened it up. I'm like, is this the right thing? I'm just seeing like things about wood chairs, something like that. Is this the right class? All right. So was it employee that we're storing information? Okay, and what information are we storing?
Weight, height, age.
Names. So first and last name.
Height, weight,
First name, last name, height, weight, age. That's it. Why would they be storing the weight of an employee? That's just creepy. All right, so we want to think about the types for this. So what's this guy? So when I say we're going to store some information about something, what is this guy going to be represented as in our project? What kind of animal is this? Cat, dog, or object? This is an object. Objects have three things to keep track of. What are the three things? Fields, constructors, fields, constructors, and methods. All right, so these are going to be the fields of our employee class, right? First name is likely going to be a string. This was supposed to be L name, but I'm guessing that auto-corrected. Last name is going to be a string. Height. We could do this a couple different ways. We could store height in two parts. We could store it in like feet and inches. If we wanted to, we could store it as a string and break it up. So we could decide to do like 6 foot 5. We could store it in, what do we think? Do we want to do it in, you never know, you might want to like sort on height. Who's the tallest person? Like that sounds like a good thing. So maybe store this as 2 integers, feet and inches. Okay, so 2 ints, maybe feet and inches. And you could have approached this differently. We're just kind of going through the planning process. This is how I would have approached the assignment. So before you even start writing code, we're going to sit down, we're going to design our class. We're going to decide this is the pieces of information we're going to keep track of for employees, and this is what they're going to look like. Weight. I hate those scales that give the weight with like the point something.
Why?
Well, when you start getting up near my weight, the 0.2 doesn't really make a whole lot of a difference. It's like 387.2.
When you're cutting weight, it matters.
Every ounce counts. Yeah, like when you go to home, like this morning, I was at Home Depot buying a step stool thing for the makerspace because now we have all the printers on this big rack mount system, and Blade can't reach the top shelf. So we had to get the step stool, and like the heaviest duty they have only goes up to 300 pounds. I mean, there are people that weigh 300 pounds. That's like not like a astronomical weight. Right? And this thing even had like a thing for your toolbox. It was supposed to be human plus toolbox.
How much is the toolbox?
Good question. How heavy is a toolbox? I'm going to operate off the guys that they put this on there for insurance reasons, and it's the 300-pound capacity is like what they can confidently, safely say it holds.
That's 1 foot on, just like.
All right, so how do we want to represent weight? As a float? Double? We want to give it as like a fraction of something? Say good enough? That way we'll have a little bit of mixture of different types in here to practice. And then age we'll obviously do as a long, so we can do number of seconds old you are. Actually, that is something, a common thing in computers, a little inside information. So we have something called the epoch. This is the number of seconds since January 1st, 1970, I think is the, So most operating systems have something called an epoch, which you can calculate a, you know, all sorts of date information and stuff like that off of that number. So that ends up being the number of seconds since 1970. But eventually you're going to run out of space in a long. But that is a seconds since 1970. All right, so, but we won't do it like that. Should we just have age as a int, number of years old? We could also put, maybe have birthday, but maybe we'll upgrade this with dates at some point, but I don't want to complicate it. So for right now, we'll just have this guy as an int. All right, so this is going to be our class for employee, and I'm going to come in here, and we're actually going to start a new project. So we're going to say new project. And this is going to be a project with an empty activity in it as my starting point. So I'll hit next. And we're going to call this guy CSC250 Fall 2019 Employee Manager. Something along those lines. We'll leave everything else the same. We'll hit finish. All right, so here's our new project. Is the other one still open? I'm going to go ahead and just close that other project in the background. All right, so here's my base thing here. I probably would just go ahead and run it real quick and make sure you have a hello world thing working. I don't remember, is this the fast one or the slow one? This is the slow one. We're going to kill that. And go up to AVD Manager. I don't remember what's the fast one anymore.
I'm using the Pixel 2 API.
There, we're just going to do Pixel API 23. Looks fast enough. Let that guy finish booting here. Okay. And then I'll go ahead and hit play. And this should launch on that device. And there's my hello world. All right. So whenever you start a project, always start off with that kind of first go-to step. Make sure you got something running. That way you know if anything else breaks, it's not related to that. All right. So now what we want to do is we want to go ahead and have a data entry screen for getting some of the stuff. We're eventually going to actually move this to multiple screens. So we're going to start talking about moving into different screens in our application as well. In fact, I'm going to go ahead and show that now, just from a perspective of we might want to have an application that, you know, we kind of have an add new employee screen, something like that. And then you maybe have a list employees screen that shows you all the employees you currently have, something like that. So let's go ahead and do the process of getting us to a second screen. All right, so I'm gonna, even though this wasn't part of the homework, we'll just interject it in here. So here is my application right now. Shrink that down, shrink that down. All right, and for constraint layout here, I right click on this and I say convert view, and I'm gonna convert this to a linear layout so I can create my amazing interfaces. And I'll make sure I set that guy's orientation, which is currently set to nothing. I think vertical might be the, here, I'm gonna not actually do anything there for a second. I think vertical might be the default. Nope, horizontal's the default. All right, so I'll change this guy's orientation from nothing to vertical. All right, and I'm gonna go ahead and take my text view out of there. And I'll leave the button in for now, but we're gonna have the button's height set to, why is that taking up the whole thing? That's interesting. I'm going to drop that button in there again. I think it's because I switched it from horizontal to linear. It must have done a weird layout thing. All right, so I'm going to change the text on my button to say, add new employee. All right, so add new employee. Now, the way we accomplish things, and I'm just going to say it at the high level right now, the way we get to another screen, we can also do other things with this tool, is through something called an intent. So an intent allows us to let an activity know that we intend to do something else. For example, go to another activity, which is going to be the guy that we're going to show. All right, so to go to another activity, we're going to need a context and the class name of the other activity. All right, so what I'm going to go ahead and do is I'm going to build a second screen, just something we haven't done yet, but you're going to see it's pretty much identical to what we've done so far. And I'll just go ahead and put a text thing on it that says, you know, screen 2 or something like that, just so we have evidence that we have arrived at a new screen. Okay, so I'll come back into my project here. Now, if you notice, some of you have asked about this, I can like minimize my project up here to this little tab. That gives me kind of a bigger space here to see. When you want to bring it back, you just click on that and it re-expands it so I can get over to where my code is. All right, so underneath our employee manager, near where main activity is, I'm going to right click. I'm going to say new. I'm going to scroll down to activity. So the stuff that's in has the little green Android-y guy next to it. That's Android specific stuff. We're going to create a new activity here. And for the immediate future, actually probably for everything in this class, we'll always be creating empty activities. There are some things in here that kind of pre-build it for the type of interface you might be wanting to work with, but we're always going to start with a empty activity. So I'm going to call this guy employee entry activity. All right, and we'll tell it to generate a layout file that's already checked for us. It names it for us automatically. Now make sure that you have launcher activity turned off. An Android application can only have one launcher activity. That's the activity that launches when you start the app. Okay. This guy can be your launcher activity, but that means your previous guy will no longer be your launcher activity. Yeah. You can change it later. You can go into the Android manifest and change who's your launcher activity, so this isn't like a one and done and can never change it again thing, but we want this guy to be a secondary screen in our application, so we'll leave that unchecked. Package name, just let the default be there, and the source for this, leave it as Java. Kotlin is like another language that's trying to compete, let's call it, with like Swift. Java is still the go-to move for Android apps. So we'll click finish and we see we get another activity up here, and then under our resources thing, we also have another XML file in there. So nothing new. We have two separate activities with two separate interfaces for them. Okay, and for this activity entry screen, I'm just going to go ahead and drag in a text view real quick. Actually, just so I don't forget, I'll go ahead and convert my constraint view to a linear layout. And then I'll change that guy to vertical. And we'll just call this guy, we'll put a little text view in here that says screen 2. And we'll bump the size of this guy up there to there. Now I can even read that. All right. So if we arrive at this screen, we should see a big screen 2 at the top, proving that we've gotten here. Okay. Now, the way we're going to get to the screen is by clicking this button. How do I make buttons work in Android? Go ahead.
Well, make it work when you do like on-click me button, like from
yeah.
activity.
Yep. Okay, so I would set the buttons on click equal to something. What else do I have to do? This is MVC in action, right? We have two things. We write some code in the activity that is the guy that gets fired when we set the on click to that guy, right? So we'll go into my main activity because this is the guy that houses that button. That button lives in his interface. Okay? So activity main, that's the name of the interface here that has the button in it. All right? And that's the button I want to work. So I'll go into main activity. I'm going to go ahead and create my public void on add employee click. Yeah, say that's good enough. And this guy's going to take in a view as a parameter. All right, and leave it at that for now. I've put this guy in the right format. He has to be public. He has to be void. You can name him whatever you want. He has to take a view as a parameter, but you can name that whatever you want. But this is the signature for the MVC that Android understands. By writing a function that has this signature out here now in activity main, when I click on my button, I now have an on click that has found that. This is MVC in action. Model view controller, it's a good idea to separate your your logic from your interface from your data. All right, so we're seeing it in action here by writing that code over in our implementation, in our logic. It's now becoming available to us in our interface. All right, so now this button will call that code. Everybody's clear on that? Okay, this is one of our go-to moves in Android. We're only going to learn like 4 or 5 things in here. One of them is when button is clicked, do something. Okay, so we're going to go back here to our main activity, and the thing we're going to do here is we're going to create an intent. So I'm going to create an intent called I. This is going to be a new intent, and I'm going to give this guy the current context, which is going to be this, and then the name of the class that we're going to go to, which is employee entry activity dot class. All right. Now the context with this guy is kind of a I'll just put it underneath it here. This is where am I starting? I'm going to say usually an activity, always an activity in our current use of this. So, when somebody asks you a question, in what context you're referring, something like that, they're asking, give me the surrounding story so I can understand the question you're asking relative to that story. This guy's saying, look, you intend to do something. Tell me a little bit more about where the launching pad is. Okay? So we are doing something relative to this. And in this case here, who is this? What does the this keyword refer to generically? Let's say generically and then tell me specifically what does the this keyword refer to here. Go ahead.
It's referring to itself from within itself, in this case, the main activity class.
A specific instance of the main activity class. Yep. So the this keyword is how an object refers to itself from within itself. In this case, it's referring to this specific instance of main activity. That's who this is in this case. So the context of this intent is to say, I am launching the second screen from here. If I'm the activity, it is that first activity that is launching the second activity. All right. Now an intent is, we have lots of good intentions in our head, right? But sometimes we don't go and do those things. Like my wife's been asking me to buy rock salt. I think we're going on 3 weeks now. And what's really bad is I've been to Home Depot several times in that 3 weeks and have failed to remember to get it each time. Including today. I was there at 6 a.m. Yeah, it's terrible. It's really, and I was just yelled at about it last night, and I still forgot it today. Okay, we have good intentions. Okay,
We don't
but
care.
intentions don't actually occur until we execute them, right? All right. So this intention doesn't actually accomplish anything at this point. We have to ask the current activity to start start the next activity. So we're going to say this dot start activity. And notice there's a whole bunch of them. We want the one that just takes a single intent as a parameter. And the intent we're going to do is just called I. Okay, so we intend to go to the second screen. Now we tell the current activity to actually start the activity that is the second screen. That makes sense? So now I'll go ahead and launch this guy. Oh. There's my button. I click it. It takes me to the second screen. Now how do I get back? Okay, so how many of you are Android users? Several of you. You all know how to get back. How many of you are iPhone users? Okay, iPhone users, your apps have to have a back button, right? So something that's built into Android as part of the hardware interface is there is a back button built into it. All right. What that translates into is that our activities are collections of, or our applications rather, are collections of activities. It's a stack of activities. So when I click this button, what's actually happening is a new activity is created and it's laid on top of the current activity. Next semester, we're going to be dealing with the stack data structure. And we're going to be writing stacks where we have push, pop, and peek, where we can push things onto the top of the stack. We can pop things off the top of the stack. So when I hit this button, a new activity is born, and he's pushed on top of my activity stack. Now I see that. When I hit this back button, whatever's on top is popped off, revealing the previous thing, this guy. Make sense? So that's how activities work. All right, so we're going to go to our new, we're going to do our homework effectively here in the second screen so we can do some data entry stuff. That makes some sense? Yeah. All right. Okay, so now we're going to go in here and I already have my object imagined here. So I'm going to go ahead and set this up. Let's go build an employee object. This is not an Android thing. This is a plain Jane Java employee object. Okay, so we'll come in here. And we'll right click. I'm going to create a new Java class. Very top there, notice he doesn't have the little Android-y logo next to it. This is the same exact thing we were doing inside of Eclipse. Eclipse is an IDE that supports writing plain Jane Java applications. Android Studio is an IDE that's designed for writing Android applications using Java, which means that these guys share a whole lot in common. We just have the extra Android-y stuff built in there for us to do Android-y things. All right, so I'm going to create a new plain Jane Java class here, and we're going to call this guy an employee. All right, and we made it like this. Now, do I put a main method in here? I do not. Tell me about that. Why does this guy not have a main method? What is the main method? If we think back to, I mentioned it initially in 200, and then we reviewed it here in 250. We said the main method, we said all programs begin and end with main, right? Now, I promise you, if we went digging, at some point we would find a public static void main somewhere inside of the Android launch cycle, right? Way down deep in stuff that we're never going to touch. Okay, this is just part of how Android apps work. It's built into our package here. So when we write stuff, our starting point for most of our screens in this, our version of main, if you will, is this thing called onCreate. So we're experiencing our applications, our interface through an activity, a visual interface that has this onCreate stuff. So things that we would have put in main before, we'll now put here. But in your Java applications, when we were writing stuff inside of Eclipse, you would only have a single file with main in it. Because when you run that program, that's the file that actually runs. He's the conductor, right? He tells you what your entire application is going to do. You know, he might deviate and you might go to another class, which takes you to another class, which takes you to another class, but at the end of the day, you're coming back to main. Okay, and that's a true statement whether we're dealing with Java, C#, C, C++, really any of those things. If you remember back from when we did this in Python, early on in the semester, we just wrote our thing just kind of linearly, so just went through it in order. But then once we started dealing with objects, we had that name equals underscore underscore main. So that was kind of the main method in Python. Python maybe makes it feel a little bit less structured, but that's what it effectively did. That's where your program actually began, was where main was when you ran it. Okay? So we're not going to put a main in here because this is not a file we intend to run. This is a part of the supporting cast of the play that we're putting on here, right? Okay, so an employee plays a role in our application. He's going to hold the information about individual employees that we'll read in. He does not actually, he's not part of the execution of starting our program. So no main. Make sense? Questions about that? Pretty common. If I think back to the exam, there were several people that put public static void main string array args or something like that in some of their objects. You know, it was correct to have it in your hello world program, right? Because that's a program, because the question was write an error-free hello world program, something that'll run. Okay, not just main, but the whole program. So public class hello, opening curly brace, public static void main string array args, system.out.println hello world, blah, 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 right? Because that guy, if you compiled it and ran, it would run main and call the system.out.println hello world. That's why we had main in there. When we created our object for that, I don't remember what the object was. Was it a student or something like that? Whatever it was. We did not have main because that was a tool we were going to use in the context of our larger application. Same thing we're doing here. Okay, so I'm going to come back in here and we have these guys here. I'm actually going to steal that real quick and see what this does. Perfect. We'll just leave it. So we're going to have a string named fname and a string named lname. We're going to have a int height underscore feet, height underscore inches, and then we're also going to have an age, which is an int. And then we're going to have a double that is our weight. All right, so now this is allowed. The way I have this written here is perfectly legal. I would recommend not writing it this way. I would recommend putting each field on its own line because now when you look at this, what are you looking at? It's kind of a play-by-play of the attributes of this object. It's a lot cleaner to look at this way. What's an employee? An employee is keeping track of a first name, a last name, a height in feet, a height in inches, an age, and a weight. Make sense? So at a glance, this guy tells us about that stuff. Okay. Now I'm going to go ahead and I'm going to add one additional thing in here that we have not done in the past because it's going to allow us to talk about another concept. Up to this point, all these guys have either, well, the official security settings for these guys is called package level, or if you've ever done C++, this would be a friend type. But typically we have, and we've seen public a lot, right? We have three different options. So we're going to call this class member security. We have public, we have protected, and we have private. Private means only accessible inside of that class. Protected means only accessible inside of that class and children of that class. So that supports inheritance. If we have something that is something else, we would have access to his protected fields within there. Public means accessible everywhere. And if you put nothing here, no security setting, this is package level security where it is accessible anywhere within the package. All right, so these are the different security settings we can use. At this point, we've always either seen nothing or we've seen public in front, and I've always just said, trust me, that's just the way it is. Okay, go ahead.
So no security setting is equivalent to public?
Almost. Public says it's accessible literally everywhere, even outside the package. No security setting, package level security where it's only accessible inside of the package. And notice that we get this default package thing here. This guy, well, actually our package name is not called default package. That was an Eclipse thing. Our package name is called COM example CSC250 fall 2019 employee manager. So anything that's public is accessible anywhere inside of that package. But if I had a separate package in here where I wanted to organize my code in different ways, it wouldn't be directly accessible. I would have to import that package to give myself access to it. All right, now here's the rule of thumb. Make everything private and loosen the settings as needed. We could say exceptions. Main is always public. It is very, 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 very likely that classes are public. Okay. So really, I am saying make all fields and methods private initially. And then decide, does somebody need access to these outside of this class? And we'll see that by example here, because this is going to lead us into a concept called setters and getters here in a few minutes. Okay. Now, am I correct in assuming that this homework assignment that I gave you for today was really a redo of the previous one, just more practice? So we're okay looking at new things here?
Yeah.
Okay. We're going to still ultimately solve it, but I want to keep us rolling forward. Go ahead.
How does public and private relate to static and non-static?
Unrelated. So static has to, let's put it on a slide because it's a fair question because it kind of feels similar, right? So let's call it public, private, protected versus static, non-static. So static, non-static dictates who owns a, we'll call it member, and tells us how to call it, whereas public, private, protected dictates where we are able to access a member, kind of like variable scope, something along those lines. Go ahead.
Is there like a combination of these two things that like, you just not use because it wouldn't make sense? Like a non-static public or what, however, is there?
Actually, I don't necessarily think so. You would never make a constructor. Well, actually, that's not true either. I was about to say you would never make a constructor private, but you actually could. You can make a private constructor that's only callable from within that class, and then you might have a public constructor that makes a call to your private constructor. So that would be fine. But you're asking, would you ever have a static member that couldn't be either public, private, or protected?
Yeah.
No, I think all of them would make sense in different contexts. Yeah, I think so. Certainly any combination is legal. There's going to be kind of what makes sense for your application. And what I'm kind of telling you here, and maybe we even put this, I'm calling it a rule of thumb, but the industry term might be best practices, something like that. So best practices, good coding would say, make your stuff as locked down as possible and then punch holes where you need it to be more accessible. Sometimes that'll feel a little bit anal, right? That you're, having to do all this extra work. Like you might have a variable where I want to get the first name, but the first name is private. Well, can I just make that public so I can get the first name? Well, that actually has some downsides. If you're the only coder who's going to ever be working with the code and that's just convenient, no biggie. But if somebody else might be using your code, you're better off making it private and then giving them accessor methods to get to either the ability to change that variable or at least the ability to read that variable. And we'll look at those things. And I'm calling them accessor methods, but it's just a simple method that either returns the value or sets the value. It's not a special kind of method. It just happens to be a method that is doing a very simple task, reading and or writing a field. Yeah.
For constructors, should those just be treated as like how the class is? So if the class is public, should the constructor be public?
Unrelated. So almost always your classes are going to be public. I guess you could probably have a argument for a protected class if it was something that was supporting children beneath. But I would say the security on the constructors is unrelated to that. You may very well have a lot of public. It's probably very common to have a public constructor, or at least a constructor with no security setting in front of it, where it would be accessible in the package. But there would be situations where you either wanted to have a private constructor where it was kind of an internal constructor that was used in terms of another constructor. So another constructor would say, all right, you give me the couple of things that I need from the user, and then I'll do the rest of the magic internally here. Then you could also maybe have a protected constructor that takes that example one step further and says, maybe there's some situation that a child of mine might want to create an instance of me where it's not something that could really be done external, but a child might have the right information to be able to call it. Something like that, yeah.
And then just one other thing is, if there is a public method, and in that method it called private methods, is that able to be called publicly, even if it calls private methods inside of it?
Sure.
Okay.
Yeah, because all private says is you can only access it from within that class.
Okay.
So if you're inside of a public method, you can access that from anywhere. And if that public method lives inside the class with the private members, he can call them to its heart's content. Because he's in that class. Right? Yeah.
Is there a time when you would make a private class?
I think it's legal, but I can't come up with an example where that would be a thing. I think it's legal because of the syntax. Although it's possible that they give us an error on it. Yeah. Not allowed here. Yep. Yeah, but it wouldn't make sense because now you can't actually create instances of the class. So how are you going to get to the class if you can't get it? It's a infinite loopy thingy. All right. So given my rule of thumb here, I'm going to make these guys all private. And that's going to be our new norm. When you create fields, you make them private and only make them less than that if it's necessary in your code. This would be best practices for good programming. All right, questions about that? And we're going to see it in action here. We haven't really seen it work yet, but trust me on this. This is our step one. Make them all private. All right. Now we're going to have a constructor here for our employee. Now we can certainly say we're going to make this a private constructor, but the reality is we're pretty sure we're going to want to have access to this guy outside the class. Almost always we make constructors public. You actually can probably make the argument to not put anything in front of it. It's only accessible inside your package. But if you're reading somebody else's code, we'll make this guy public. So public employee. And this guy's going to need to take in some pieces of information. So first name, string last name, int height, feet. Let me minimize this. Int height, inches, int age, and double weight. All right, so those are all the pieces of information we're reading in, and we'll set f name equal to f name, l name equal to l name, height in feet equal to height in feet, height in inches equal to height in inches, age equal to age, and weight equal to weight. Now again, variables resolve to their most local definition. So when I say f name here, the most local definition of f name is the guy that was passed into this constructor. Where I say this dot f name, I'm talking about the field that is owned by this particular instance of employee. That's referring to this f name. That clear with everybody? All right. So that's what an employee is right now. I'm going to leave it like that for right now because this is going to show us that we aren't going to be able to access any of those things. After I build an employee, which I can do right now, I can say, I want a new employee and here's all the information you want. And Java will say, got it. And now I say, okay, I'd like to know that employee's first name. Java's going to say, sorry, that's only allowed inside the club, only allowed inside the employee object. So I would have to either make this looser or I'll have to write methods to make this accessible. And these are called accessor methods. So access to private members, old school. Actually, is that how they do it? Would it be old school? That? I think it's that. Old school, they would call these guys accessor methods and mutator methods. Accessor methods give access to a private member. Actually, let's call it read-only access to a private member. Mutator methods give write access to a private member. It allows you to mutate it. All right, that makes sense. Now, cool kids. Oh, so you wouldn't even let me write it the cool way. All right, so we now call them getters and setters. Getters allow us to get the value of a private member. Setters allow us to set the value of a private member. The actual implementation of these methods has not changed. Just the way we refer to them has changed. This is all just naming convention. All right, so getters and setters. Getters give us read access. Setters give us write access. Sometimes we'll need read-only access. Sometimes we'll want read and write access. So for instance, if we create an employee, we might not want to be able to directly have somebody else who's using our employee object change the name of our employee from Mike to Bob. right? But they should be able to read the name of the employee. So, you know, we might have a public string get f name, and this guy will return this dot f name. Make sense? All right. That's a getter. Nothing special, no special syntax. It's a method that gets the value of a private member. We would just call that a getter. Now, what's nice for us in Android Studio is I can right click here and I can go down to generate. And I can say I want to generate getters and setters, or I can just do getters. And I want to be able to get the first name. I want to be able to get the last name, get the height, feet and inches, get the age, get the weight. Do I need to be able to set any of those things? Or do I really just need read access to those? Maybe later I might want to be able to update something, but for right now, and it just creates those functions for me. I can do the same thing for setters, or you can do them both at the same time, getters and setters. All right, make sense? So that becomes pretty convenient, especially given that we're making everything private by default. Now it's just a right click and a couple of extra clicks and you have all your methods generated for you. Now you might decide that there might be some kind of restricted access to who can get this stuff. Maybe they need to be authenticated or something like that. So you can throw more logic in here if it makes sense. Similarly, it might make more sense to talk about getter or setters that way, where maybe you can't set the weight to a negative number. But if I generate the setter for weight, it's just going to take in a value and set the weight to that value. It's not doing any checking. It's not doing anything special. It's just saying blah. So I might say in here, if weight is greater than or equal to maybe 1, then we'll let them set the weight. Otherwise, you can't set somebody's weight to -7 pounds. That makes sense? So understand that these are conveniences for generating the setters and getters for you, just to kind of get the tediousness of that out of the way. But you still might go back in and make some updates to it if it made sense for your application. All right, but right now I'm just going to leave everything with my getters, just because we now have access to my private members. Okay, so any questions about that? So now I have an employee class with a bunch of private fields, the ability to publicly create an employee, and now I have read-only access to all those private fields. So somebody external to this class can't change my data, but they can get the data. Yeah.
What would be the difference? So couldn't you all put, that seems similar to what we did with, so what's the difference between doing this and just putting them all in just giving them all this dot weights? You say that you can change that.
If I didn't put private in front of them, you mean? What's the difference between this and if I left private off the way we did before?
So after you put the public method up there, you made like separate methods for each variable.
Yep.
Here. So the reason you did that was so that you could restrict access, basically.
Well, access is restricted because I put private in front of all these.
Right.
Now, if I want to have access to those variables, if I want to get the first name, the only way I can do that outside of this class is by calling getFname.
Got it. Okay.
If I'm inside this class, I can just say fname. I was able to say this.fname. Even though it's private, private says you can only access it inside the class in which it was defined.
So by defining,
I'm inside the employee class here.
Using the variable. Okay. So by having the variable having its own like little method and returning, you can basically access
private members externally, but only read access. So not full access. If I had this public up here or nothing up here, anybody external to this class could read or write it. They could just change the first name to Bob. In this case, they cannot change the first name. They can find out what the first name is equal to. They can get its value, but I've restricted write access.
Got it.
Okay? So that's the reason to do this type of stuff. Now, we might say most people aren't going to be overly malicious with our employee objects, but in a real life setting, maybe they would be. Right? You know, chances are if you were getting into Banner and you got a student record or something like that, grades would be read only. You would need some sort of special private access in order to update a grade. Just get A's the first time around, then you don't have to worry about it. All right. So we have our employee. We can now build some employees. Let's go build our interface here quickly. So we'll do this on our second screen here. So we'll put employee entry like that. I'll go ahead and set the gravity of this guy to center. All right, so now I'm going to need a first name, a last name. So I'm going to need a bunch of edit text, right? So first name is just going to be plain text. Last name will be plain text. Then we need height in inches, height in feet, height in inches. So both of those are going to be numeric, unsigned, right? Decimal numbers, because we don't need negative numbers for those. So we'll use that guy. And remember, all this is giving us is it's a normal plain Jane edit text. It just has the keyword previously set on it to only give you access to the things you want it to have access to. So both of those are going to be numeric. Then we have weight, also numeric. And then we have age, also numeric. Which one did we do as a double? I think numeric will support doubles as well here. So I think we're fine. Okay, so we're going to call this guy, we're going to go up to our hint, and we'll say first name. And we're going to take the text out of that, so it's blank. Take the text out of this guy. We'll set the hint to last name. And then we'll set this guy to height in feet. Height in inches. It's a little bit misleading, but let's just roll with it. Because somebody might say, well, I'm 6 feet tall or I'm 72 inches. Whatever. Use the interface right. All right. All right. So then we have age and weight. All right. And then what we'll go ahead and do is we want to name these guys. So I'm going to name this guy FName ET. I'm going to name this guy LName ET. Height underscore feet ET. Height underscore inches ET. Age ET and weight ET. And that's just my naming convention for edit text. All right, and then we're going to want a button. Now, I very often will put my button at the top. Why do you think I do that? Yeah, sometimes if you do a big long thing, the keyboard will end up blocking your button. There's all sorts of probably better ways of doing it, but like I said, we're getting towards the edge of my interface design abilities here. So you can put your button wherever you want, but just so, especially within the emulator, so I don't have problems clicking it, I'm gonna put it inside of we'll put it at the very top. Now, if you did have a whole bunch of stuff you needed to enter in here, we could actually embed all of this stuff inside of something called a scroll view, which allow you to scroll through the whole interface and see it. And we'll probably use that. Actually, we will use that when we start showing you lists of stuff. All right, but I'll go ahead and I'll give myself a button. And I'll put the button right below employee entry. We'll just call this guy, he'll be the create button. Okay, so now we have, these guys all have reasonable names now. I want to give myself access to those edit texts inside of code. Again, MVC, right? Okay. So I'll go into, let's see what we're doing on time. Okay, so I'm going to pause this for a second because I want to go over and show you the list thing. So back on our main screen, I'm going to have another button. And this guy's going to say employee list. And we're going to have that guy take us to a new activity. So I'm going to create a new empty activity. And we're going to call this guy employee list. Make sure launcher activity is not clicked. All right, and this gives us now an employee list design thingy. I'll go ahead and throw a text view on there. Oh, I need to update my constraint layout. Convert view to linear layout. Change its orientation to vertical. Just throw a text view on there real quick that has nothing. It just says text view. That's good enough for right now to test it. I'll go back to my main activity. I'll copy my button code, and this is going to be on employee list click. And what did I name it? Employee list dot class. So that's where that guy is going to go. I probably should have named that employee list activity, but is there a easy refactor in here? There is. All right, so I'm going to go to that employee. I really wanted to keep my naming conventions there. So employee list, I want it to be employee list activity. So I'm going to right click on that. I'm going to say refactor. I'm going to say rename. Will it do all of it? We call this employee list activity, and I'm telling it to search and rename everything. I'll click refactor, so notice it updated it here. And it should have updated it in my manifest. It did. Even though this is something you never look at, I just wanted to prove that it did. Okay, so that allowed me to undo the mistake of having the name of the file wrong. Okay, so I'm going to be calling employee list activity as my second screen. I now have a second button. I just go and let that second button know that his on click calls the on employee list thing. Now when I run this, I can go to that other screen. If I go back, it still takes me to this screen. Okay. Trying to think what we're going to have time for. Okay. I'm going to leave this button on here right now. Just we're actually going to do the list stuff next time. I'm going to go back into my employee. And we have our employee entry activity. I'm going to give myself access to these things. So I'm going to create private edit texts. And we're going to have fname et, lname et, height, feet, et, height, inches, et, weight et, and age et. Is that all of them? All right, so I gave myself variables up there for holding them, and then I'll actually set them inside of onCreate. This dot fname et is equal to this dot find view by id r dot id dot fname et. And I'm going to steal most of this and just update it at the end. So this dot lname et, the lname, this dot weight et, this dot age et, this dot height feet, this dot height inches. All right, so now I have access to all those guys. And now I'm going to go ahead and I'm going to have a function that will get called when I hit my button to create. So this is going to be public void on create employee button clicked. This guy will take a view as a parameter, and we're going to go ahead and read in these pieces of information. I'll go ahead and put them into separate variables first and then pass them in just to be very explicit about it. So I'll say string fname is equal to this dot fname et get text dot toString. That's lname, that's height, that's, no, actually, let's do these separately because some of them we're going to have to convert. So lname, from lname, this dot weight, int weight is equal to this dot weight et dot get text. Now dot toString, so that's a string, but I want to get the int version of that. So we need to juice this guy, right? So that's integer dot parse int, and I pass it that string. So that'll squeeze the integer out of that string. Int age is equal to integer dot parse int this dot age et dot get text dot toString. And then we have our, didn't we have something that was a double? Oh, but I'm not reading it in as a double. Did I write it as a double? What did I write in employee? Oh yeah, I read it. Okay, so I wrote weight as a double there. So that means that my weight here should not be an int, it should be a double. And we do have a double dot parse double that knows how to juice a double out of a string, conveniently enough. Okay. And then I have int height feet is equal to integer dot parse int this dot height feet et get text dot toString int height inches is equal to integer dot parse int this dot height inches dot get text dot toString. All right, so now I have my pieces of information, right? And I want to go ahead and create an employee out of this. So what I'm going to do for a moment here is I'm going to actually say private employee, the employee at the top. So I'm just going to give myself an empty employee object that I can now set. I'm going to start this guy, just for logic leading up to your assignment here, I'm going to start this guy off at null. He has nothing in it. And so then on create button clicked, we're going to say if this dot the employee is equal to null, we're going to do all this stuff. This is a new employee. Else, this is an employee we are updating. All right, so we'll read in all this information, then we'll say this dot the employee is equal to a new employee, and we'll pass it F name, L name, what's the next thing my employee actually takes? Height in feet inches. Height feet, height inches, then age and weight. All right, and there is my employee there. And then if I wanted to display the employee in a text field or something like that, I could do that. All right, so for your homework, we are going to allow the create button to also update the current employee object. So I've already given you this else here. Note that you only have getters for your private employee fields currently. You may need to change that. Got it? So we're going to practice with setters and getters using the private things. You're going to just reuse the same edit text that you already have, except when you hit that button a different time, it's going to situationally either create a brand new employee or it'll say, you're updating the employee you've already created. Make sense? All right, I'll go ahead and push this up to GitHub. So I'll share a project on GitHub. And I'll put the assignment up, and I'll see everybody on Thursday. Remember, today, student, faculty, staff, Bible study. God and grub. Go to the cafeteria, sign in, get your lunch, take it down to the terrace room. Bible studies from noon to 1.
I'm just having trouble using the import to GitHub on Android Studio, so I just made a repository and directly uploaded the main, the employee class, and the XML.
Okay.
Is that okay for now?